you had a Delta math on this kind of stuff. So if you are confused, hopefully this will clear some things up. I apologize for not being here on Friday. Thanks. I missed y'all too. I would have rather been here than where I was. So, give me questions about your homework. Everything. All right, let's look at number 6. 6 is log x equals 2 over 5. So remember, this is where I do the little, and I think I can't remember if I showed y'all Friday or not, or Thursday or not. Whenever I'm going from exponential form to logarithmic form or vice versa, whenever I'm going from log to exponential, and that's all this is asking me is to write it in exponential form. So you take the base, this is the base, raise it to this power, and it equals the x. So it makes like an E when you loop around. It's kind of a little trick that I remember to help me put it in the right form. But because this is natural log, that means the base is E. So I do E to the 2/5 logs always equal exponents equal x, and it's in exponential form now. Log E and ln, they're the same thing. It makes sense if I got no. All right, what else on that homework there? How about the second set? Writing going from exponential. Number 10. Thank you, Mia. Number 10, 3 square root 2 to the 4th power equals 324.
Oh, did Brady give you Brady?
What's wrong? What? All right, so the base here, what is the base? 3 square root 2, right, of 324 equals that exponent, which is 4. Right. 12. So 12 is 1/5 to the -3 equals 125. So I got log, what's the base? 1/5 of 125, and logs always equal, right? Again, equal exponent. Yes, Armand. Log is not a number, it's a function. It's kind of like a multiplication or division. It does things to, it's a function. The inverse of a log is an exponential. They're opposite. Yeah. Square root is, well, whenever I say exponential, I'm talking about a number to the x power, not exponential like x to the second. Yeah. Oh, Armando, you mean if there's not a number there? Back before calculators, they had tables that gave them, you looked up the values in a table because you can't really calculate it by hand. All right, somebody asked me for one, and I'm sorry. Which one did you say? 4. Number 4. Log of 1/10 equals -1. Something's missing. What's missing? The base. If the base is missing, what's the base? 10. So I get 10 to the what power? -1 equals 1/10. Yeah. When do you flip what? So if you raise, see how this one's to the negative first? So a negative exponent means you make it positive, but you move it to the bottom of a fraction. So as I'm trying to find what logs equal, like in that section 13 through 24, I might have to make them negative exponents. Like do one? Yeah, yeah. What's wrong, Chase? ln has a base of e, and if there's no base indicated and it's a straight, like a common log, it's a base of 10. ln is log base e, and no base, the common, is a 10. All right, Liz. You said a negative exponent, right? Look at 16. So I need to tell what that exponent needs to be. So in other words, if my base is 49, what exponent can I put here to make this become 1 over 7? What? So on this, some of them you will and some of them you won't. So the ones that you could use on a test, you'll have somewhere you have to show me your work without a calculator. This would be one I'd need you to do without. Because we're gonna start doing some more, and you have to know how this works. So here, what power do I have to raise this? Well, the first thing I see is I need to flip it over, right? And the flipping is going to be the negative exponent part. So I know it's going to be negative something. So if I get this in the bottom, now what do I have to do to make 49 become 7? But you can only use exponents. 1/2, because an exponent of 1/2 is what? What does that do? What's an exponent of 1/2? Square root. It's a square root, right? Anything to a 1/2, x to the 1/2 is the same thing as the square root of x. So if I've got 49 to the 1/2, that's 7. If I've got 49 to the negative 1/2, that's 1 over 7. Yes. So the answer would be negative 1/2, because I'd need to flip it and take the square root. Yes. So I would want you to show your work going through how you reason through like this. Like there's some that you'll get. I could give you a quiz before the test that's a non-calculator quiz that would be ones like this that you could do without a calculator. All right, give me any others that you got. That's all. Okay. All right. Remember, logs are what? Starts with an E. Come on. Exponents. Logs are exponents. All right. As we go through these, remember whenever we did those 7 properties of exponents in Algebra 2, and everybody's like, oh, that's so easy. And then we put them all together, and everybody's like, oh, that's so hard. It's going to be kind of the same way with logs, okay? Each one of these individually is going to look easy, but when we put them together, you're going to start going, I don't know about all that. So stay with me, okay? We did this in one of the, I don't remember which semester, but one of the semesters we did this. Probably did. All right, second semester. Properties of logs, and then we will put them all together for some practice. All right. At the top of your sheet, notice it says a common log is a log base 10. A natural log is a log base e, and we're going to run through examples that do both of those. All right, basic properties first. The first one, log base b, which means the base could be anything in the whole wide world, okay? Whatever that base is, if this number is 1, this is going to equal 0 every single time. Yes. no matter what. Because if you think about the way exponents work, anything that I raise to the 0 power is going to give me 1. That's the only way to get 1, right? Is if I raise it to the, yeah, probably did. And then the other property is if the base is the same here, this is going to equal 1. Now I want you to make a little note here, because the bases being the same here, if the bases are the same and then there's an exponent on this one, it's going to equal 2. It's actually what this is doing is pulling this exponent, this right here, and that's what it's equaling. So if those numbers are the same, then I pull that exponent off. So log base b to the 5th power would be 5. Whatever, as long as these numbers are the same, this is what it equals. Okay. All right. Of course, it works the same if you look over. I don't know why those are in. Oh, those are examples over there. So good. Go over on the right side there. What is the log base 6 of 1? 0. What is log base 4 of 4? Y'all okay?
Yeah, that's what she said. Sneak this if I ever heard one.
All right, let's look at the first property, product property. If you remember that logs are exponents, then the properties we're going to run through are going to make a little more sense, okay? Product property, if I am multiplying, you're exactly right. If I'm multiplying with the same base, okay? Now look, this has to do with the bases being hooked to the log this way, okay? I can split these up, log base b of m plus log base b of n, because the base is the same. That's right. If I move from left to right, this is expanding. You remember what it's called if I move from right to left? Condensed. So, for example, look at the condensed column there. If I have the log base 3 of 8 plus the log base 3 of 3x. Now this only works when these bases are the same, right? And these bases are the same, so because I am adding, I combine them with just one log, and I multiply these two together. So what do you get? (24x). So you multiply the through. When you condense, you should have log written just one time. What? Why what? So if you take one log and you write it in multiple different logs, that's expanding. If you take multiple logs and you shrink it down to just one log, that's condensing. So this asks me to condense down to a single log.
But I forgot that we had clubs, and so I wasn't going to your advisory because we don't have.
What do I say?
That you weren't here on Friday. I was like, told him that you weren't here, so I didn't go to any advisory. So I didn't get any lunch or anything.
I ain't never seen no man.
Basically what it is. I'll bring it to him after.
All right. Now the expanding one here is a little bit harder. Remember, we're going to take some concepts and kind of make them a little bit more difficult than what you would initially do. So let's see. The log of x squared minus x minus 2. Okay. So it says to expand, but I don't have a property to expand with addition and subtraction. I only have one to expand that I've learned so far with multiplication. So how could I write this as a multiplication problem?
X minus.
Yes. Well, not
Multiply by element.
close. You can't change its value. You have to keep its value the same, but you can rewrite things, and you can rewrite them in different ways. This is one of the things that we talk about a lot in calculus is how can we manipulate and change it to look different but keep it the same. So we're changing it. We're changing it to multiply so that then I could split it up into natural log of x minus 2 plus natural log of x plus
Uh,
Anywhere you can't see. I did
It calms you down.
hypnotic sleep therapy the other night. It worked very well.
Quotient property. So if you add when you multiply, what do you think you...
Did we finish the other one?
That's just the answer.
That's just the answer. It's expanded because that's what you're trying to do is just expand it. All right, so that's exactly right. If product tells me to add, then quotient tells me to subtract. So if I have log base b of m divided by n, then I could expand that by log base b of m minus log base b. Notice I'm writing the log twice. Expanding, excuse me. Excuse me. Thank you. Expanding goes this way. Condensing goes this way. In other words, if you start here but you end up here, you've condensed. And if you go from left to right, you have expanded. I would write this. Yeah. I just wanted you to see the expanding. If you write multiple logs, you've expanded. If you just write one log, you've condensed. Yes, as much as you can. All right, so let's look at the examples there. Condense, and then I have the log of 80. No, I don't see a base there. What does that tell me? 10. 10 is my base. I'm subtracting, I'm condensing down to 1, which means I do what? (80/16), which I could then reduce, right? What does that reduce to? 5. 5. You can. You can. So if you have that, that's fine. Either one. Either one. It's kind of like writing an exponent of 1 on something that doesn't have an exponent, or a coefficient of 1 that doesn't have a coefficient. It's fine to write it. It's just not necessary. Armando? All right, let's expand. Log base 2 of x over 5. These are those I told you. They seem easy, right? You look at them and you go, oh, that's, yeah, I just apply that. But whenever you have to do it cold from just, it just says expand and you don't know what you're doing, that's when it starts getting a little harder. All right, so if you see subtraction, that means I'm dividing, or if I see dividing, I split it into subtraction. If you see multiplication, ret, that means add, or if you see addition, that means multiply, okay? If, yeah, you're always looking at what this number's doing. All right. Thank you, William. What? All right, teach the lesson. Let me just teach the lesson. All right, power property. That's it. We don't do anything else with it. We're just simplifying right now. We will equal it later this week, but right now we're just working on simplifying. All right, last one's the best one, I think. Power property. This is everybody's favorite because it's so easy. This is where the exponent comes around to the front and multiplies. Y'all remember that? Again, expand goes this way, condense goes, ooh, condenses. Everybody in my class, first block and now, has just been, I just don't want to be here. I just hate this. I hate math. I just want to go home. I don't even like this. What time is it? What time is it now? What time is it now? When do we get to go? Monday.
There you go.
Everybody's got the Mondays. Well, they hurt my feelings in first block. Because they're just whining and complaining, and it's like, oh my gosh, but it's so much worse. And like, one of them... All right, let's finish.
What did it say? Oh, who wrote that?
Paris.
I just saw it. I was wondering if she
That is not Harris's handwriting. Oh, Harris didn't write that.
Nice.
Oh, maybe I should just quit.
No, Harris is looking.
Let's do.
Randy's serious.
No, I've talked too many of y'all into doing it, and I'll be here next year for y'all. All right, condense this one. I get log of 9 to the third. You can leave it like that, or you can write log of 729. Either one's fine. Isn't that what it is? And then on the expand one, I have log base 7 of 3 to the 2x. You just bring that 2x around the front. So it's 2x times log base 7 of 3, and that's it.
Wait,
That's expanding.
wait,
That's expanding. I'm not gonna go through that last line on your thing because we did that Friday or Thursday because that's where you just do log A over log B and you put it in your calculator. Do it anyway. Yeah. Are you OCD about not having your chart filled out? Well, just quickly, if you just want your chart filled out, I have log base B of A. If I do change of base, what does that become? Close. Log A over log. It's always the number that's written the biggest that goes on the top. So if I have log base 5 of 138, if you put that in your calculator, what are you putting in? Log 138 divided by, or you could do, remember Thursday we talked about, it could be any base, so you could use that LM button on there and you could do that. You'll still get the same thing. They had that on the board? Oh, you could. I told them some of them to know, just to know. Like if I had log base 7 of 49, like you should know without a calculator that that's 2. But yeah. Yes, you will get decimals. If you have to use your calculator like that, you're going to get decimals. What are you doing? It's actually a good hiding spot because we can't see right. Let's go stand up. I need to stand my lazy butt up anyway. All right. What do you think? Do some together?
No, do the.
No, I don't know what they're looking at.
Can we get the homework and then we just want
Let's do one condensing and one expanding where we pull all the properties together and then. Condense down to 1 log. Mark, set, go. Condense this down to just 1 log. Condense it down where you only, there's 3 logs right now. I only want you to write it with 1 log. To condense, yes, that's the end goal. Did y'all hear the question? Is that always the end goal? If you are condensing, yes, that is always the end goal, is to get it down. Armando? Armando, what should I do first?
Take them back to class.
I would work inside the parentheses first. Order of operations, right? All right, 2 log 4. What are you going to do with 2 log 4? Close. You're close. It's what? What did you say? I'm sorry. I'm not saying it. All right.
Oh, it'll be log 16. Right?
It'd be log 16. Why, Luke? Why? The 2 goes over there. Yes, yes, yes. All right, so I got log 72 minus 1/3 log 16 plus log 32. You can't add them together, no. It'd be what, Gina? That's exactly right. That's exactly right. I'm going to multiply them together because I'm adding, right? So I got log 72 minus 1/3. What is 16 times 32? 512. What now?
So, you do negative 1/3 to.
I gotta do this 1/3 to here. That's exactly right. Before I can combine these because there's something out front, right? So this is out of this parentheses, but each of these pieces need to be completely simplified before I combine them. So for this one, so now I got log 72 minus log, now 512 to the 1/3. Well, I'm gonna keep the subtraction here, make it 1/3. What is it? 8. Why is it 8? The cubed root of 512 is 8. Now what? Log of 72 divided by 8, which is, there you go. All of that, and I come down just to log 9. Okay.
Okay, that is, so we squared 2 to the 4. So that's how we got 6.
Yeah.
So then we did 64. Why would you put it as an exponential value when that's not an exponent outside?
If you ever multiply outside, this is this property. Mm-hmm. All right. Let's do an expand one. That one is about as hard as it gets, yeah. You thought it was easy?
With all the same things.
That's the way it feels. Whenever you see them, it's like, oh yeah, that's easy. But then you put them all together, you go, what the heck? You want to do another condense? All right, let's do another condense. Lost some chords up here. Let's do one more condense before we expand. Try this one on your own, and then let's come together and do it.
Wait, I thought we were.
We are, but we're going to do one more condense. We'll do one with some variables instead of all the numbers. All right. Try. You want to make sure everything's simplified first. I always go through and do power property first. Okay. Once you do power property, then you can go through and start combining, and always left to right. So the first two. And then if there's another one, then I'll take that answer and take it to the next one. So let me show you. Like here, I'm going to take care of my exponents first. Just like regular order of operations where exponents come before multiplication division, I'm going to do exponents before here. So I got log base 3 of a to the 3 over 2 minus log base 3, 16a squared to the 1/4. Now, 1/4 as an exponent means what? Fourth root, right? What times itself 4 times? So look, I can take this to both of these pieces, and this is going to be important, and I'm going to show you why. I'm going to keep carrying this one down. Remember, I want to simplify each piece completely before moving on to the next step, okay? So here, what is 16 to the 1/4? 2, because 2 times 2 times 2 times 2 is 16, right? So 2, and then 2 times a 4th. Y'all can do this. What's 2 times a 4th? A half. Now, each of my logs individually are simplified, yes? Now I can combine them into one. So, because I am subtracting, I do what? Divide. So I got log base 3 of a to the 3 over 2 divided by 2a to the 1/2. Now I simplify this one if I can. You just subtract your exponents. What's 3 over 2 minus 1/2? 1. 2 over 2 or 1. So I've got log base 3. The a is up front and it's got an exponent of just 1. And the 2 stays down. Remember, it doesn't move with that a. It stays on its own. It's its own piece. And that's the answer. A to the 3 over 2 over a to the 1/2. I would do a to the 3 over 2 minus 1/2 because I subtract if that's those properties of exponents. So I get a to the 2 over 2, which is the bottom. It goes away when you subtract them. So you're used to seeing ones that look like this, and you would subtract and just get x to the first. This one, they're just fractions, but it's the same property. There's a lot going on. One property at a time. One property at a time. Make sure they're valid properties when you do this. I know. All right, let's expand. Yep. Yes, I always start with power and then clean up each piece. Okay, simplify each piece after you do power, and then move left to right with your addition and subtraction. Do 2 expands. I'll do an easy one and then a little bit harder one. Expand. C squared.
What? He's about to give you a spanking? Like those old teachers. Put your hand on the table.
I don't know. I was just looking at that out loud.
Yeah. No, listen, he makes a she said he was gonna be on He's smack Armando with a ruler. They used to give out.
What you got, Luke? There's one more thing you can do. All right, so you want to start as far out as you can and work your way in when you're expanding. So I'm going to start with this 4, and I'm going to pull that out front. Log 4 c squared over d. Now be very careful because understand something. This 4, no matter how you expand this part, the 4 sits outside of all of it, okay? So if you ever do that in the beginning, it's a good habit to put it in parentheses so that you know whatever you do, I keep working inside these parentheses, okay? So I'm going to split up. So I get 4, and I'm going to do those parentheses. That's exactly right. I'm going to split up my numerator and my denominator, and I split it up with what? Subtraction.
Go ahead and write it.
Well, there's one more thing. What do you notice? The squared. If you can invoke any property, you do it. So this squared, but it's going to come around just in front of this one. So I've got 4 times 2 log base 4 of c minus log base 4 of d. So you could leave it this way, or you could distribute that 2 through and have 8 log base 4 of c minus 4 log base 4. Either one of those, either one of those is an acceptable expanded form. Yes. What did I say, the 8? The 2, oh yeah, the 4, sorry. I think most students find expanding easier than condensing.
I feel like there's less room for error.
Another one, or you want to start on your homework and then I can answer? Another one. Hard one? What did he say? Now he's being nasty. Armando, you're going to have to come up here and sit with me.
I didn't say you did.
Expand. Remember, radicals are exponents. Remember that. Radicals are exponents. Radicals are exponents. Right, Malaya? What are radicals? Exponents. Radicals are exponents. Mark said go expand. Whoa. I don't know. I would begin, if you are stumped as to where you should start on this, I would probably start by splitting that fraction up. Whole top, whole bottom, because there's really nothing else, right? But also, okay, let's start there. So log base 2 of the cubed root of x, what goes in the middle? Minus log base 2 of x squared plus x. And that's in parentheses because that's the entire denominator. Okay? Now, Ella, what exponent? Why, Armando? Yep. So here's what happens with this. I change this to that 1/3, and you're exactly right. That comes around to the front now. So I've got 1/3. So anytime you see a radical, make your brain automatically go to fraction. And if you see a fraction exponent, make your brain automatically go to radical. So you could, but it's only going to apply to the top one. You want to make sure it only goes to the top one and not the bottom one also. So it wouldn't be out front in parentheses like the other was because it's only hooked to the top. Now, look at this one carefully. Can I expand it any further?
Yeah. Oh, no, you can't. That's not different.
No. Remember, expanding, guys, expanding takes multiplication and turns it into addition, but doesn't take addition and turn it into anything. So there's nothing else I can do. And that's it. That's